Hey there everybody, and welcome to our newest lesson on probability. Today our I can statement says, I can determine sample space and probabilities for compound events. So we're still talking about compound events. Remember that compound event is when you have more than one thing happening. Like you might flip a coin and then draw a marble out of a bag. Or you might be making a one-topping pizza and you have to choose the crust, the type of cheese, and the topping. That's 3 different events happening. In this first example, we're going to a theater and we have to choose which movie. There's 3 to choose from. And then you have to choose the early show or the late show. So what are all the different possibilities for that? Now we're going to start out by making tree diagrams, kind of like we did yesterday. But by the end of this first page, we're going to be looking for maybe a rule to make things a little bit easier if we don't like drawing out all of those trees. Imagine we had a real movie theater where they showed maybe 15 movies and they had maybe 8 show times for each movie. That's a whole lot of different possible outcomes. So maybe there's a shortcut math way to figure out all those outcomes without drawing the entire tree. Like I said, we're going to be talking about that at the bottom of this page. We don't have a notes page today. This is your assignment, so go ahead and work with me and we'll get started now. So let's read the instructions first. It says create a tree diagram to show the sample space for each of the compound events. Use initials or abbreviations to keep the outcomes as simple as possible. And then some advice here, just write small because you're going to need the space. This is true. Let's read the problem. The Triplex Theater has the following movies and show times. 3 movies, Bucket of Fun, The Great Bozo, and Pickle Man. I've got to say I haven't seen any of those movies. Have you guys seen those? Are they good? Feel free to write me a note if you want to. I love movies. Okay, so we have 3 different movies. And then the next event would be the early show or the late show. So let's go ahead and make our tree diagram. So for Bucket of Fun, I'm just going to write a B. For Great Bozo, I'll write a G. I'm going to try to space this as much as I can. And then Pickle Man, I'll write a P. Pickle Man, that's a fun title. I might have to see that one, just based on the title. And then we have early show and late show. So I'll do E and L for each of those. So for B, we need an E and an L. For G, we need an E and an L, and for P, we need an E and an L. All right, so our tree diagram will go like this. And then so our first outcome is B and E. So basically that would mean Bucket of Fun, early show. And then our next one would be Bucket of Fun, late show. And then we have G, which is what? Great Bozo, early show. I did that wrong. Try again. I did this wrong too. Oh my goodness. All right, there we go. Got that fixed up with a B and an L. This one should be a G and an E. So Great Bozo early show and then Great Bozo late show. Now Pickle Man early and Pickle Man late. So Pickle Man early, Pickle Man late. So BBGG, PP, and then EL, EL, EL. Okay. Just had to check myself. Looks like I got it right. So that was number 1. What about question A? How many outcomes are there in the sample space? All right, this is where we go to this column where we wrote all the little letters out and we just count them. So let's count them. 1, 2, 3, 4, 5, 6. Sounds like there are 6 different ways this choice could turn out. So we'll write a 6 there. Pick one outcome in the sample space, and this is the sample space right here. This list of possible outcomes is your sample space. So pick one outcome in the sample space and explain what it means. Okay, I'm going for Pickle Man. Let's do Pickle Man late show. So PL here means we're going to see Pickle Man and we're going to the late show. That's what I would write here. I'm not going to take your time writing that, but that means Pickle Man late show. So how many options are there for the first choice? And then for the second choice. Okay, what they mean by this, the first choice is this one. The first choice is which movie are we going to watch. So how many choices are there? Boom, boom, boom. You could also look at the first column if you want. Boom, boom, boom. 3 choices for the first choice. 3 options for the first choice. Now what about for the second choice? That's talking about this one right here. Early show or late show. Well, how many? 1, 2. Early or late. So there's 2 options for the second choice. That's all you got to do for number 1. We're going to take a look next at number 4. So you'll be doing 2 and 3 by yourselves. You can pause and do them now, or you can just come back to them after you're done watching the video. It is up to you. It says Jen's soccer team is playing 4 games in a tournament. All right, question A. How many different total outcomes are there in the sample space for the 4 games? All right, so each of these 4 games, how can they come out? Let's not include tie in there. Let's just go with win or lose, okay? So I'm going to kind of label my columns because we need 4 games, and I just want to make sure I keep it all straight. So game 1, 2, 3, and 4. That's just to help me stay organized. So for game 1, they might win or they might lose. Now for game 2, same idea, they might win or lose. So we'll do a win or lose for each of these. Okay. Now game 3, I think I'm already running out of room, guys. For game 3, we're going to do a win or lose for each one of these. Okay, so this one can have a W or an L. This one will have a W or an L. This one will have a W or an L. And this one will have a W or an L. Yikes. And the problem is that fit, but now what about game 4? I need wins and loses for those also. Let me draw some lines. Maybe that would help me. WL, WL, and so on. You just keep trucking. WL, that's a W. Oof. WL, WL. Okay. And then you could finish writing your little tree branches. Alrighty, we've got our tree diagram. So now if you want to write out all the outcomes, I'm not saying you have to, not at this point. Let's just see how the problem shapes up. But if you were going to do it, you would do win, 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 win. So 4 wins for the first one. And then you would do win, 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 lose for the second one. And then you would do win, win, lose, win. And if your tree diagram is neater than mine, that is awesome. I'm kind of struggling with mine. Win, win, lose, lose. Okay, so we got the first 4. Let's go ahead and read in the problem a little bit more. So first question here, how many different total outcomes are there in the sample space for the 4 games? So how many different outcomes? Well, we have 1 for each one of these, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Looks like there's 16 different outcomes. Okay. How many different outcomes for the first game? Okay, so for the first game they're playing and they might win or they might lose, right? That's 2 different outcomes. What about the second game? Now be careful here because it's a little confusing the way it's worded. When they say how many outcomes for the second game, that doesn't mean all 4 of these, because this would be the outcomes for the first and second game together. When you're looking just at the second game by itself, what can happen? Win or lose, right? That's 2, so we're going to write a 2. What about for the third game? Again, we're looking at it by itself, so we don't need all of these. That would be for the first, second, and third games together, right? For just the third game, by itself, what can happen? Win or lose, that's 2. Okay, same idea for that fourth game. What can happen in the fourth game? Win or lose, that's 2. All right, so we got that filled out. And guess what? It looks like we didn't even have to write all the letters all the way down, so whew, lucked out on that one. So now here's the important part. I'm going to draw a big star there. What do you notice about the number of options for each individual event or choice and the total number of outcomes for each compound event? Okay, let's take a look, see if we can make any observations. If you have already done 2 and 3, then you should look at those also because that's just more clues for you. But I've done 1 and 4, so those are the ones we're going to look at. So first of all, there's 3 choices or 3 options for the first choice and 2 options for the second choice. So 3 for the first choice, 2 for the second choice gives us a total of 6 outcomes. Okay. All right, so what about down here? This is much more complicated. You've got 4 different events happening. First game 2, second game 2, third game 2, and fourth game 2. And all of those together give us 16. Are we adding the numbers together? 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. No. And 3 plus 2 is 5. So we're definitely not adding the numbers together. Any other ideas what we might be doing? And again, if you did 2 and 3, compare these numbers with the number of outcomes. But it's fine if you haven't done them yet. So maybe you've thought of this already, maybe you haven't. But let's try multiplication. What if you did 3 times 2? Let's see, 3 times 2 gives us 6. Oh, hey, that's good. Let's look at number 4. 2 times 2 is 4, times 2 is 8, times 2 is 16. That's good too. And that is in fact our shortcut rule. That is how we're going to find the total number of outcomes if you have a compound event. So you're going to multiply the number of outcomes for each one of the steps in the process, for each one of the events, and that'll give you the total number of outcomes. So like in problem 3, the number here times the number here times the number here should equal the number here. And in question 2, the number here and the number here, you multiply them together, it should give you the total number of outcomes in the sample space. So go ahead and draw your tree diagrams, think through it as you're doing it, see if you can see this happening. You can kind of see it doubling and tripling if you're looking at it the right way. Now, using this new knowledge that we have, let's go to the next page. Now, I love these instructions. It says, use what you learned on the previous page, in other words, that multiplying trick, to answer the following questions. You do not need to create a tree diagram unless you find it helpful. So if you want to draw it, absolutely draw it. Sometimes seeing it just makes it concrete and really helps us see what's going on and understand the problem. But if you don't want to draw the tree diagram and you find the multiplication trick to be helpful, then go with it. Absolutely. So number 6, let's read it. The eBox laptop computer offers the following options. Okay, so for screen, you can have small, medium, or large. For memory, you can have 4, 6, or 8 gigs. And for colors, you can have gray, blue, or white. Okay, so what are the number of options for the first choice? That would be the screen size, small, medium, large. That's 3 choices. Second choice, we're talking about memory now. How many options do we have for that? 1, 2, 3 options. Okay, and what about that third choice? Now we're talking about colors. What are the options there? Gray, blue, and white. Okay, 3 options. Awesome. Now how many outcomes are there in the sample space? You can draw your tree diagram if you want. I'm just going to multiply the numbers together. 3 times 3 is 9, times 3 is 27. And now list at least 2 of the outcomes in the sample space. Now if you've done your tree diagram, just pull 2 of them out and say what they mean. I'm just going to make them up, 2 of the outcomes, and then say what they mean. So I'm going to say medium screen, 8 gig, and I'll go with blue. So that means medium screen, 8 gigs, and blue. Whoops, there we go. And then you would choose another option. Maybe you would go with large for gray or something like that. Make sure you do 2 outcomes. I'm going to skip that other outcome for now, and we're going to scoot down to problem number 8. So on number 8, it says a bag contains 3 ping pong balls. 1 is red, 1 is blue, and 1 is green. A ball is drawn, its color is noted, and then it is returned to the bag. Then a second ball is drawn. This is called drawing with replacement. This is an important concept. You might get into it more next year than this year, but for this year, for this problem, I should say, just remember that after you take the ball out, we're putting it back in. So like if you choose one ball and it's blue, you're going to put that back in before you make a second choice. Okay? So that is drawing with replacement. What are the number of options for that first draw? So on the first draw, it could be red, blue, or green. 3 options. And now we're putting that ball back in, and we're doing a second draw. How many options are there? There are still 3. There's still going to be 3 balls in the bag. So how many outcomes are in the sample space? 3 times 3. That gives us 9. Now list 2 of the outcomes. Okay, let's say red, blue. Red, blue. What's another outcome? How about green and then green again? That could happen. Okay, done. Now let's look at number 10, which is similar but different. Okay, a box contains 3 socks. 1 black, 1 white, and 1 brown. What is the sample space for drawing a single sock? Not returning the sock to the box, then drawing a second sock. This is called drawing without replacement. You will want to draw a tree diagram. Okay, so we're recommending that you draw a tree diagram here. I want you to think through it, like how many options do you have in that first choice when there's 3 socks before anything gets drawn? And then in the second event, like the second time you draw, how many socks are in there now? So how How many choices do we have? Remembering that you're not putting that first sock back in. Like I said, draw your tree diagram, see if you can answer the questions, and definitely save this one for last. This one's a little bit extra, so as you're spending your 30 minutes on your assignment, do the others in order, and then if you have time for this one, go ahead and go for it, see what you can get done. Thanks so much for watching. Let me know if you have any questions. I love hearing from you, and I'll see you later. Bye.